Hello everyone, today I Arsha of class 10D going to perform few tests to distinguish between ethanol and ethanoic acid. So first of all, we should know about some basic physical properties of both of them. So if we talk about the ethanol, it belongs to the second member of the homologous series of the alcohol, and the ethanoic acid belongs to the second member of the homologous series of the carboxylic acid. If we talk about the taste of the ethanol, it has a very burning taste, whereas ethanoic acid has a very sour taste. Ethanol has a very pleasant smell, whereas ethanoic acid has a very pungent smell. And if we talk about the boiling point of ethanol, it is 78 degrees Celsius, due to which it is very volatile, whereas the boiling point of ethanoic acid is 118 degrees Celsius. And there is one more property of ethanol, that is it is miscible in water in all proportions, and it is also a very good solvent due to the presence of the hydroxyl group. Now we know that these both are the most important compounds of the carbon. So why we are learning about these two, like what is the day-to-day life application of both of them. So if we talk about the ethanol, as we know, that is the most important compound in making the alcoholic beverages, and it is also known as the motor fuel because when mixed with the petrol, it can be used very efficiently. It is also used to sterilize the wounds and the syringes which are used in the hospitals. And one more application is that it is used to make the medicines, as it is a very good solvent, like in making the cough syrups. Now if we talk about the ethanoic acid, its applications are that 5 to 8% of ethanoic acid in water makes the vinegar, which is a very good preservative in pickles. And it is also used to make the ester, which is a very sweet smelling compound which is used in making perfumes. So that was all about the physical properties of both of them. Now we'll do two tests to distinguish between both of them. So the first test is a physical test, which is the litmus test. And for this, we need the apparatus we need here are alcohol, ethyl alcohol, and here is the ethanoic acid. And I have the blue litmus and the red litmus here. So first of all, I'll take the red litmus and I'll pour it in the ethyl alcohol, and we will observe no change. Now if I pour the blue litmus in this alcohol, again we'll observe the no change. So this clearly depicts that ethyl alcohol is neutral in nature. So now here query arises, like why this is a neutral. So this is neutral because of the absence of the hydrogen ions, and it doesn't easily dissociate the ions, therefore it is a neutral. And now I will pour the blue litmus in the ethanoic acid. We'll slightly observe an orange layer. It will slightly change into orange. Now why does it slightly changes into orange? Here again a question arises. This slight color change is due to because this is an organic acid and it is a very weak acid, therefore it just changes into a slight orange color, and it also has the pH of 4, which clearly depicts that it is a weak acid. Now we'll do one more test for that is the sodium bicarbonate test, for which I need a test tube, and I'll take this ethanoic acid and I'll pour it in the test tube. Now I'll take the sodium bicarbonate and I'll pour it into it. We can observe the brisk effulgence here, which clearly depicts that the carbon dioxide is liberated here. And one more test which we can do here is we can do the matchstick test. So we can do the matchstick test. If I'll take the ignited matchstick near to this mouth of the beaker, it will extinguish, and this clearly depicts that the CO2 is liberated here. Now if we talk about the reaction of sodium bicarbonate with the alcohol, it will not react to it because alcohol does not react with salt, as sodium bicarbonate is a salt. Now we'll talk about the products which were made here in the reaction of ethanoic acid and the sodium